Hello, this is a short video presentation continuing our discussion of solving systems of equations by elimination. There will be a third video on elimination, possibly a fourth, but for sure a third. All right, if we look at what we did yesterday, we added two equations together to eliminate, hence the word elimination, to eliminate a variable. All right, that's why it's called elimination. We eliminated a variable. So let's look at this equation. Negative 12x plus 2y equals negative 18, and 6x plus 3y is equal to negative 3. Now I see, if I add these together, the x's, if I add the x's together, nothing eliminates. If I add the equations together and look at my y's, nothing eliminates. There's no sense adding the two equations together. So now I'm going to do something different. Now I am going to divide or multiply one or both of the equations by some number so that I eliminate a variable. So I look at this, I see that the 6 is half of 12, forgetting about the sign. 6 is half of 12. I could multiply this bottom equation by 2, and then when I added the equations together, the x's would eliminate. Or, more easily, I could divide this top equation by 2. I could divide negative 12 by 2, and I get 6, negative 6. Then when I add the equations, the x's will eliminate. I can divide 2 by 2, no fraction. Negative 18 by 2, no fraction. Now please pay attention. I talked about this yesterday. When we do elimination, we work sideways. We do not work top down. It's the only time we work sideways. All right, negative 12 divided by 2 gives me negative 6x. 2 divided by 2 gives me 1y. And negative 18 divided by 2 gives me negative 9. Then we have 6x plus 3y equals negative 3. That equation remained unchanged. When I can add the equations together and eliminate a variable, and right here we see, when we add these two equations together, the x's are going to eliminate. When I can do that, I then put a line under my equations and add them together. Those eliminate. 3y and 1y is 4y. Negative 9, I don't have a y here, Muscat. Should be no y there. Negative 9 and negative 3 is negative 12. We divide both equations by 4, and we get y equals negative 3. Okay? Now, when we do more complicated equations, and we string these along like this, we'll sometimes have 3 or 4 different equations. Working sideways is the only way to do it and have an organized problem. All right? It's mandatory that you work sideways. Now, once you do this last part, I don't care where you do it. I pick one of my equations. I can pick one of these two, or I can pick one of these two. Doesn't matter. It doesn't matter at all. I am looking at this, and I'll probably pick this equation right here to work with. All right, I'll highlight that. I need to find out what x is. I don't think it matters in this problem at all which one we use. So, and we can do this wherever you want to. We have 6x plus 3y equals negative 3. So we have 6 times whatever x is. We have 6x plus 3 times whatever y is equals negative 3. Y we found out was negative 3. So we have 6x minus 9 equals negative 3. Add 9. 6x equals 6. We divide by 6. X equals 1. My answer then is the ordered pair 1, negative 3. All right, and we are done. Okay, what we are doing is writing down the equations in order, and today I'm not going to switch up the order for you. The x's, the y's, equals, and the constants, and then we multiply or divide one or both of the equations. Today it'll only be one, and then we add the equations together. Remember, we do not want fractions. Okay, I'm going to write out the next equation. 2x plus 5y equals 12, and 3x plus y equals 5. Now, we want to add or subtract these two equations so that something eliminates. Well, the x's won't eliminate, neither will the y's. So we are going to multiply or divide one of our equations, all right, by something. And again, we are working sideways. I'm going to multiply the bottom equation by negative 5. If I multiply it by 5, I'm going to have 5y and 5y. They won't cancel when I add, so I'm going to use a negative. And the way I show what I'm multiplying by is I just write this number here. And then I multiply everything. 3 times negative 5, negative 15x. 1 times negative 5 is a minus 5y equals negative 25. And the top equation stays the same. 2x plus 5y equals 12. My y's eliminate. Right here, the y's eliminate. And I end up with negative 13x equals negative 13. And divide by negative 13, divide by negative 13. And x is equal to 1. Now, I can use either equation, it does not matter. I can solve this to the right, I can solve it down here. It doesn't matter where I solve it. I'm going to solve it over here. 3x plus y equals 5. I chose this equation because the coefficient here is a 1. So when I solve, I don't have to divide by anything. So I have 3 times x, which is 1, plus y equals 5. We know that x is 1. So we have 3 plus y equals 5, minus 3, and we end up with y equals 2. My ordered pair then is 1, 2. And we are done. Box up my answer. Again, we wrote down the equations in order. I have my x's here, my y's here, my equals here, my constants here. All right? They have to be done in order. And then, oops, I lost my box. And then we want to add the equations together to get something to eliminate. That wasn't happening, so I multiplied the bottom equation here by -5. And I multiplied everything. Don't forget to multiply this by it. And then, the 5 to get the -25. And then we add the equations together. One of our variables had better eliminate, and then we solve. I hope this helps you out, and have a great day.